For other videos or problems like this for Intro to Stat Methods for Business, you can go to Sarai Studies, link is in the description box below. The reason we use autoregressive models is for data that is collected over a period of time, so time series data, that is autocorrelated, meaning that the data points are highly correlated, highly related to previous data points. So if we have this data point over here, if I'm using a first order model, that must mean that this data point is highly correlated with its previous data point, so one behind it. If I'm using a second order model, that means that this data point is related or highly correlated to the second previous data point, so 1, 2. So it's highly correlated to 20.9. If I'm using a third order model, that means that this data point is highly related to the third previous data point. So 1, 2, 3, so to 21.3 and so on. Now, all this might look so complicated. It's not, I promise. First things first, we're dealing with time series data. So we know that we never use the actual years. We code the years because if we don't, then it gives us a weird output. So we just give them, a little code name, a little ID, 0, 1, just number them. We're not going to use it in this case, but make sure you always do that when you're going to be using code here. And then what we do is we do 3 columns called lag 1, lag 2, and lag 3. So these are just going to be our Y values. So lag 1 is really just first order model Y values, and the first order model Y values are always just going to be the previous. So this is your Y value and then -1 previous. So if we go over here, what's the previous Y value for this one? Well, there is no previous Y value. That's why we skip 1. So this 1 here just means skip a cell and go to the next one. Because for this one, what's the previous Y value for 20.6? 19.6. There we go. So that's lag 1. Scroll all the way down. Lag 2, if you see a 2, that means skip the first 2 cells and go to the next one. Because there is no second previous Y value for this one, and there is no second previous Y value for this one. So we have to go to the next one. The second previous Y value for this one is 1, 2, 19.6. Then we scroll all the way down. If you see a 3, that means skip the first 3 cells, go to the next one, take this value, go 3 up, 1, 2, 3. That's the previous Y value. Notice how they're all the same. Scroll all the way down. And then all we're doing now is we're just finding out which model is going to be better by looking at the adjusted R-squared and the p-value. How do we do that? We're just going to output 3 summary outputs, and we're going to start with the highest model, which is the third highest model. So for this one, we're going to go to data. We're going to go to data analysis. If you don't have this, I'll link to a video in the description box below to teach you how to pull that up. Go to regression, click OK. So your Y range is going to be your actual Y column, but we're going to start with what data we have. And so the first row where we have all the data is in 2004. So our Y is going to be from 2004's data and forth. And then our X range is going to be our lags. So notice, even though they are, our previous Y values, there are actual X values in the equation. Like that's what you're going to be plugging into your equation to your model to get a predicted Y value. So that's why they are our X range. That's what's going inside the equation. So this data over here. And then there are no labels. Output range is going to be here. Click OK. And then we're going to look at the adjusted R-squared, and we're going to look at the p-value. So adjusted R-squared is pretty good. That means that this model, this equation, will explain 90% of our variance in our data, but the p-value is really not good. So it's not significant, right? Because it's greater than 0.05, or alpha by default. And so this is why we start with the largest order, the highest order, which is the third one in this case, because now when we go on to the next one, we can just not include the third one because we know that it's not significant. So then we're going to do AR2, our autoregressive model 2, and that's just going to be go to data, data analysis, regression. So for the X values, the first row that we have all of the data up until lag 2 is this second row over here. So I'm going to include all of this data over here. And then my Y value is going to be from 2003 as well, because now we don't have to start in 2004 because we're not using lag 3. I'm not going to include labels, and I'm going to output my range right here. Click OK. Now this one's a little bit better. This one can explain about 91.57% of our variance. And then our p-value is better than this one, but still not good because it's actually really bad. Both of these are really bad because they are way bigger than 0.05 in alpha. So they're not significant models. And so therefore we're going to scratch lag 2. And then we're going to check lag 1, our model lag 1, our first order model, which is just going to include the lag 1 data. We're going to go to data, data analysis, regression, click OK. So our X values is now only going to include the lag 1 data, and I have all of the this data over here, and our y value is going to have to start in the same place, so 2002. And I'm going to output my range right here, click OK. So this adjusted R-squared is pretty good, just like the previous ones have been. And it's telling us that the model can explain 91.58% of our variance. But if we look at the p-value, it's actually really small. It is smaller than 0.05. Don't think it's 3. It's 10 decimal places to the left. So yes, it's smaller than 0.05. And if you can't do visual math, you could just simply do a function. So if your p-value is less than 0.05, which is our alpha, our default value, then tell me that it's significant. If not, then tell me that it's not significant. So it is significant because the p-value is less than 0.05, and therefore that means that this is the model that we should be using for this data because it's significant. And these two were not significant. So including lag 3 and lag 2 were not significant, but including just lag 1 was significant. So therefore we can conclude by looking at the adjusted R-squared and the p-value that the first order model is the one we should be using to estimate any future y values. And let's actually go ahead and do that. This is our model for the first order model. It's literally just y hat is equal to a sub 0, which is just your intercept, plus the slope times the y value minus previous y value. Our intercept is this, our slope is this, and then if I want to find revenues for the year 2020, then I go to 2020 and I go to my previous y value, that's 42.7. So we're going to times 42.7, and so our y hat is going to be equal to this. So our estimated revenues for the year 2020 is $43.43467. So that means that our estimated revenues for 2020 is this over here. But what if we want to do 2021? Let me bring this stuff over here. So if we want to do 2021, the only thing that we change is that instead of using the actual previous value, because we did have that for 2020, we use the estimated previous value. So this one. So this over here is going to be this. And then this is our estimated revenues for 2021. As a side note, I wanted to mention that if we had both a high R-squared and a significant p-value in AR3 or autoregressive model 3, our highest order one, then we would have just stuck to that one and used that model to predict our future y values. But because it didn't have a small p-value, less than 0.05, then we had to strip that one down and only do the summary output for lag 1 and lag 2, and that was AR2, right? And because that one didn't have a good enough p-value, then we had to move on to AR1. And so that's what we did, and we ended up figuring out that AR1, our autoregressive 1 model, was the one with both a good adjusted R-squared and a good p-value, and so we used that to predict our future y values.